Welcome back, everyone, to another deep dive. And this one is really interesting. We're going to be talking about AI and cybersecurity.
Sounds interesting.
It is. And the paper we're looking at is called SecEncoder. Logs are all you need in security. So kind of a bold claim right off the bat.
Logs are all you need, huh? Well, I guess we're about to find out.
Well, it's interesting because most language models that we talk about, right, they're trained on books or articles like on Wikipedia.
Right. Huge amounts of text data.
Yeah, this one's taking a different approach.
Yeah.
It's all about those security logs.
And that is different, like you said. And it's kind of a fascinating area because, you know, those logs, they're full of information, right? Every event, every action in our systems. But deciphering them, that's a whole other story.
Yeah, exactly. It's like a secret code, almost timestamps, cryptic codes, technical jargon. It's not exactly light reading.
Right. It's not something you'd curl up with by the fire.
Definitely not.
Yeah.
So how does SecEncoder even begin to, tackle this challenge?
Well, first of all, it's what they call a small language model. I mean, it's still powerful, but it's got fewer parameters than the really big ones, like GPT-3, And it's built on this DiBertaV2 architecture, which is known for being really good at natural language processing.
Okay.
But the secret sauce here is the training data.
Okay, what did they feed it?
A massive data set of security logs. We're talking 1 terabyte.
Wow, 1 terabyte of security logs. That's a lot of data.
It's like reading the entire Library of Congress, but in security log form.
Right. And where did they even get all of this data from?
Well, it's pretty diverse, actually. So they've got some from Microsoft's own internal systems.
Okay.
They've also tapped into public data sets like the Unified Host and Network data set.
I heard of that one, yeah.
Yeah, and they've even got logs from platforms like Azure and Linux. So it's a pretty wide range.
That's pretty comprehensive. And that's important, right? Because you want to make sure it can handle a lot of different scenarios.
Exactly. Real world stuff.
You mentioned parameters a couple of times. And for those of us who aren't, AI experts, can you explain what exactly those are?
Sure. So think of parameters like the knobs and dials of a language model.
Okay.
The more parameters it has, the more complex stuff it can handle. But it also needs more data and computing power to train,
Sure.
So SecEncoder being a small model, it's designed to be more efficient and really focused on those logs.
Okay. So we've got this model. It's designed for security. It's trained on, mountains of data. But how do you actually teach an AI to understand something as complex as a security log?
Right. That's the really interesting part. They use something called byte pair encoding, or BPE, for the tokenizer.
Okay. And what does that do?
Well, the tokenizer is like a translator. It breaks those complex logs into smaller chunks so the AI can actually work with them.
Got it.
And it's particularly good at handling those security-specific terms, things like IP addresses and error codes where regular language models might kind of trip up,
So it's giving SecEncoder a special dictionary for security logs.
Exactly. And they found that it actually works better than traditional tokenizers when it comes to security.
Wow, that's interesting. And I imagine training something like this takes some serious computing power.
Oh, absolutely. They used all kinds of advanced techniques, Azure machine learning pipelines, deep speed on-NNX runtimes, like a high-performance engine, built for this massive amount of data.
So they really threw everything they had at it, huh?
They did, and they even customized the loss function to make sure it was learning from the actual content of the logs and not just, those delimiters.
Oh, what?
Oh, sorry. The delimiters are kind of like punctuation marks in security logs, So they made sure it was focusing on the meaning and not just getting distracted by the punctuation.
That makes sense. So they're teaching it to read between the lines in a way.
Yeah, you could say that.
So they put all this work into training it, but the big question is, does it actually work? Does it live up to the hype?
Well, that's what we're going to find out next.
Okay, so stay tuned. We're going to find out how they put SecEncoder to the test and see if it can really handle those real-world cybersecurity tasks.
And if logs really are all you need.
Right, exactly.
So to figure out if SecEncoder actually worked, they evaluated it in 2 ways, intrinsically and extrinsically.
Okay, and what's the difference?
So the intrinsic evaluation, it's all about seeing how well the model understands the log data. Just in general,
Got it. Like testing its basic understanding of security logs.
Right, exactly. They use metrics like perplexity, which is basically how well the model predicts the next word in a sequence,
Okay.
And masked token prediction accuracy. That's where you see how well it fills in the blanks in a log entry.
Okay, so how did it do on these tests? Did it pass?
It did pretty well, actually, at least on data that was similar to what it was trained on. They call that in-distribution data.
Okay, that makes sense.
But when they gave it out-of-distribution data stuff that was really different from its training set, it struggled a bit.
I guess that's to be expected, right? If you're only trained on one type of data and then you see something completely new.
Right. It's like if you trained on, English literature and then suddenly someone throws Shakespeare at you.
Right. You'd be a little lost.
Exactly. But the real test for SecEncoder was the extrinsic evaluation.
Okay, and what is that?
That's where they looked at how well it performs on specific security tasks, the stuff that actually matters to security professionals.
Okay, so this is where we see if it can actually do the job.
Exactly.
So what kind of tasks did they throw at it?
They focused on 3 main areas: log similarity, log search, and log anomaly detection.
Those are all pretty crucial for security work, right?
Definitely. So for log similarity, they used SecEncoder's embeddings.
Embeddings.
Yeah, it's kind of hard to explain, but think of it as a way to represent each log entry as a point in like a multi-dimensional space.
Okay, so like a map of the logs.
Yeah, kind of. And similar logs would be clustered together,
Okay, so instead of comparing logs line by line, you're seeing which ones are close to each other in this abstract space.
Right. And that tells you which ones are similar in meaning.
That's pretty cool.
And you know what? In tests, SecEncoder did way better at this than the general purpose language models.
Really?
Yeah.
So it's specifically good at finding similar security logs.
Exactly. And that's a big deal because security analysts spend a lot of time looking at logs that are, almost the same, trying to figure out what's going on.
Right. So this could save them a lot of time.
For sure. What about log search?
Okay, so how did it do at finding specific logs?
They tried 2 approaches. First, searching by log template, and then searching using natural language descriptions, generated by GPT-4.
Oh, wow. So they used another AI to help test it.
And in both cases, SecEncoder was really good at finding the right logs.
That's impressive.
It is, although interestingly, OpenAI's embedding model actually did a little bit better on one of the search tests.
So it's not perfect?
No model is, but overall, SecEncoder still excelled,
So even going up against one of the big names in AI, it held its own.
Yeah, which shows you how much that specialized training on security logs really matters.
But what about anomaly detection? That seems like a really crucial task for cybersecurity.
It is. It's all about finding those unusual activities in the logs, the things that might indicate a threat.
Okay, like finding a needle in a haystack.
Exactly. And this is where SecEncoder really shines.
Okay, tell me more.
They compared it to general purpose models, and the results were pretty amazing, actually.
Yeah.
SecEncoder had an average F1 score that was 20% higher in unsupervised settings and 13% higher in supervised settings.
Okay. I'm not sure I understand what that means. Can you explain?
Sure. So the F1 score, it combines precision and recall. Basically, it's a measure of how good the model is at finding the right stuff and avoiding false alarms.
So a higher score means it's better at spotting actual threats.
Yeah, exactly.
So it sounds like SecEncoder is really good at understanding what's normal and what's not normal in security logs.
That's right. And that's really important for threat detection,
This is all really interesting, but I'm curious to see how these capabilities actually play out in the real world.
Great. So let's talk about some specific use cases where SecEncoder's strengths really come to life.
Okay, great. I'm ready for some real-world examples.
So one really practical use for this is log subsampling. Like imagine you're a security analyst and you've got this mountain of data after some incident.
Oh, yeah. I can imagine it's overwhelming.
It is. It's just too much to go through manually. So what SecEncoder can do is it can pick out a smaller set of logs for you to look at.
So it's like a smart filter?
Exactly. It knows which logs are the most important, and it saves you a ton of time.
That's amazing. And are these selections better than just, picking random logs?
Oh, yeah. Much better. They actually compared it to random sampling and some other methods, and SecEncoder's picks were way more informative.
Okay, so that's a huge help for analysts. But what about actually detecting threats?
Yeah.
Can SecEncoder do that?
Yeah, so they developed this tool called log pattern detection.
Log pattern detection.
Yeah, it uses SecEncoder and an algorithm called isolation forest.
Okay, and what does that do?
Well, isolation forest is really good at finding outliers, those data points that just don't fit in.
Okay, and that could be a sign of a threat.
Exactly. So SecEncoder helps the algorithm zero in on those suspicious activities.
That's really interesting. And how well did it work?
It worked really well. They tested it against a baseline method, and it did much better at spotting the threats.
That's great to hear. But, security isn't just about logs, right? There are alerts from different systems and reports and all kinds of stuff.
Right. It's a whole ecosystem of information.
So did they test SecEncoder on any of that?
They did, actually, and this is where it gets really interesting. They tested it on incident classification and threat intelligence document retrieval.
Wait, but wasn't it only trained on security logs?
Yeah, but somehow it was able to do well on these other tasks too, even though it wasn't specifically trained for them.
So it's like it learned something fundamental about security that it can apply in different areas.
Yeah, that's one of the most exciting things about this research, Maybe security logs are a way to teach AI about the core principles of security.
That's a fascinating thought.
Yeah.
So what's next for SecEncoder? Are there any limitations or areas for future research?
Oh, sure. There are always limitations for one thing. They say they need more diverse training data, and they also talk about preventing catastrophic forgetting, making sure that when it learns new things, it doesn't forget what it already knows.
Right. That makes sense. You don't want it to lose its basic understanding of security.
Exactly. They're also working on optimizing the model, making it faster and more efficient,
Well, it sounds like they're off to a great start. This has been a really fascinating deep dive. We've learned so much about SecEncoder and what AI can do with cybersecurity.
Yeah, it's exciting to see how this kind of research is shaping the future of security.
Definitely. Right. So as we wrap up, I'd like to leave our listeners with a question. What excites you most about this technology? Do you see it as just a specialized tool, or could it have even broader applications?
That's a great question. I think it's clear that AI is going to play a huge role in security in the future, and it'll be fascinating to see how it all evolves.
I agree. Well said.
Yeah.
Well, on that note, we're going to wrap up this deep dive. Thank you so much for joining us, and we'll see you next time.